In this video, we'll take a look at the weighted mean, or finding the overall mean for two separate groups. Now the weighted mean formula you can see here on your screen. It's equal to the mean of the first group times the size of the first group, which you also see down here, plus the mean of the second group times the size of the second group, divided by the sum of the two group sizes. Now here in this first example, we're going to take a look at the weighted mean when we have equal group sizes. So in this example, notice that both groups, N1 and N2, have a group size of 20 each. And the mean for the first group is 90, while the mean for the second group is 110. So plugging these values into our weighted mean formula, we can see that we should have the mean of the first group, or 90 times 20, the group size, plus 110, the mean of the second group, times 20, the size of that second group, divided by 20 plus 20. So that gives us 4,000 over 40, or a weighted mean of 100. And this is exactly in the middle of the two means. Or in other words, if we took the average of the mean of the first group and the mean of the second group, we would get 100. So notice here in this example that when the group sizes are equal, the weighted mean is exactly halfway between the two group means. So with equal sample sizes, the weighted mean is just equal to the average of the two group means. Now here in this next example, we're going to look at the weighted mean when we have unequal group sizes, and we'll see what happens here. So the first group in this example has a group size of 10 and a mean of 90. Whereas the second group, notice it's larger. It has a size of 30 with a mean of 110. So plugging these values into our formula, we have the mean of the first group is 90 times 10, the group size, plus the mean of the second group, 110, times 30, which is its group size, divided by the sum of the two group sizes, or 10 plus 30. And that gives us 4,200 over 40, or 105. Now, if you recall in our last example, when we had the exact same means of 90 and 110, but when we had equal group sizes, the weighted mean was halfway in between those two group means, or it was 100. Notice now, with the exact same means, it's no longer 100, but now it's 105. And what we see here is the weighted mean of 105 is closer to this mean, 110, than it is to this mean, 90. And if you look at these two group sizes, we can see that the second group size is larger. The first group size is smaller. So the weighted mean is pulled closer to the mean that has the larger group size. Or in other words, the larger group has greater influence in calculating the weighted mean between the two groups. So it has more pull or influence. Let's go ahead and take a look at one more example. Here we have unequal group sizes again, but this time the first group has the larger group size and the second group has the smaller group size. And we have the exact same means as we've had in all the examples, 90 and 110. So when we plug these values in, we get a weighted mean of 95. And notice this time, with unequal sample sizes, the weighted mean is closer to the mean of the first group. And that's because this first group has the larger group size. So in summary, when we have equal group sizes, the weighted mean is exactly in the middle. When we have unequal group sizes, the weighted mean is closer to the mean with the larger n, or group size. So in conclusion, the weighted mean takes into account the size of each group. When group sizes are equal, the weighted mean is exactly in between the two group means. When group sizes are unequal, the mean with a larger n has greater influence, pulling the overall or weighted mean of the two groups closer to it. This concludes the video on the weighted mean. Thanks for watching.